Hello student, today we are learning the galvanometer as a voltmeter. Previously lectures we learned that the galvanometer can be used as an ammeter. Now we are learning as a galvanometer can be used as a voltmeter. Now see that this galvanometer, when it is used to measure the voltage across the external circuit of it. For external circuit we use the R is a load resistance of it, and the galvanometer is connected parallel to the external circuit, that is parallel to the R external. To measure the voltage across the two terminal of it, we had to always connect the galvanometer parallel to it. That's why galvanometer having the resistance G is connected parallel to the external circuit having the resistance is R. When galvanometer is connected parallel to it, the current which is flowing through the galvanometer is taken as a Ig. When the current is flowing through the Ig of it, and some of the current is flowing through the R value of it, external circuit. In that case, the part of the current which is flowing through the galvanometer, and that's why actual voltage does not measure across the resistance of it. That's why we can say that the current drawn through the galvanometer and the Ig value is decreases because of it, and that's why actual voltage does not measure by this combination of it. That's why galvanometer must be connected with a high resistance. If it is connected with the high resistance of it, definitely the value of the Ig will be reduced, and this high resistance is connected in series with the galvanometer, and this both galvanometer and the high resistance are connected parallel to the external circuit of it. That's why to make the galvanometer as a voltmeter, galvanometer is connected with a high resistance in series combination. Now we are learning as a formula for the high resistance. Now here X represents the high resistance which is connected along with the galvanometer in series combinations. Now come to this diagram. In diagram, we are using as a external load resistance R. Next is a galvanometer is there, along with the in series combination high resistance represented by X, and the current which is flowing through the galvanometer, and this high resistance, that is a Ig. V is the voltage to be measured across this load resistance. For the calculation of the formula for the high resistance, we come to this that the actual voltage to be measured across the R, that is across this two terminal, across the X and across the V, means voltage V is equal to voltage across the G and voltage across the X. Therefore V is equal to voltage across the X plus voltage across the G. G means the resistance of a galvanometer. Next is that voltage across the X means the current which is flowing through the X and the current which is flowing through the G is a common, that is Ig. That's why the current into the resistance is a voltage Ig into X plus voltage across the G means the current into the resistance of a galvanometer, Ig into G value. Our aim is there to calculate the X value. Therefore, Gx is equal to V minus Ig into G value. Then X is equal to V minus Ig into G divided by Ig value. Then separating the two terms of it, V upon Ig minus Ig into G upon Ig. This Ig get cancelled. We get here X is equal to V upon Ig minus Ig get cancelled, only G will be remains, and therefore actual formula for the high resistance X is equal to V upon Ig minus G value. Now we take it as the next case of it, that is the V is nth type of the Vg, that is the voltage, galvanometer voltage is nth value of it, V is equal to NVG. Substitute into the above equation. X is equal to NVG upon Ig minus G value. Vg upon Ig gives as a resistance of a galvanometer, that is G, which is equal to N into G minus G. Taken as a G is a common into N minus 1. Therefore, X is equal to G into N minus 1. This is a desired formula for the resistance, high resistance connected in series combination along with the galvanometer, and that's why galvanometer can be used as a voltmeter.